Welcome to the virtual Grand Canyon Star Party. So tonight we're going to take a look at 10 to 12 objects over the next 90 minutes. A lot of these things that we look at are ones that you would have been able to see if we were doing an in-person star party. So that'll be kind of cool. It would be nice if we could do it in person at the Grand Canyon. We've got a picture up here showing the telescopes to kind of get you in the mood. But we are going to be doing this under some nice dark Arizona skies. So what we will be seeing is very similar to what we'd see up at the Grand Canyon. So it is nice that we've got this virtual option available. We encourage you to ask questions over the chat as we're going through, and we'll try to respond to that. And we may even ask some questions as well. So what I'd like to do now is I'd like to introduce the team a little bit. I'm Jim Knoll. I'm from the Tucson Amateur Astronomy Association. This would have been our 12th year doing the Grand Canyon Star Party. So we've done it the last 11 years, and this would be number 12. Also with us tonight is Jim O'Connor. Jim's also a TAAA member. He is the Grand Canyon Star Party coordinator, and he's been doing that for the past 11 years. And this is Jim's 18th year at the Grand Canyon as doing part of the Grand Canyon Star Party. So now I'm going to turn it over to Bernie and let Bernie talk a little bit about his telescope.
Hi, and I'm Bernie Stinger. I'm also a member of TAAA and the Minnesota Astronomical Society. Tonight, I'll be running the telescope mount, the camera, and the imaging acquisition and processing software. So I've got a lot on my plate here tonight. To give you an idea of the telescope that I'll be using this evening, I'll show you a picture of it. So on the screen here is an image of my telescope. It's about 50 feet outside of the building from me right now, and I'm presently connected up to it through a USB control cable that you probably see on the floor here of the deck that the telescope is on. So this is a Celestron C8 or 8-inch Schmidt-Cassegrain telescope. It's mounted on a Celestron AVX Go-To motorized mount. That mount is controlled through this control cable back to my computer that I'm in front of, where I'm running a program called the SkyX to control the mount and tell it where I want it to go and point at. At the top of the telescope, you'll notice there's an object here. This is called a hyperstar lens, and this hyperstar lens allows me to concentrate the light down to a focal stop of 2. So it makes the optical system very fast and be able to reach very dim objects. Mounted in front of the hyperstar lens is a Mellencam astronomy grade video camera. It's called a DS10C. That stands for Deep Sky 10 megapixel color. This is a thermoelectric cooled camera. So there's a cooler in here that keeps the temperature down and therefore the amount of noise in the processed image. So after all of that, coming down this blue cable that you see is the video signal, video information that I will be presenting to you live as the scope is seeing it tonight.
All right, very good. All right, so we're going to go to our first object. I'm going to start by showing on the planetarium program where it's at in the night sky. The program that we're using here, this planetarium program, is called Stellarium. It's actually a free download, so you can download it for free on the internet. It's at stellarium.org. And it's a great little planetarium program to show you the constellations and where objects are in the night sky. So we're looking to the southeast right now in the constellation of Serpens. And we're going to be looking at an object called M5. It's a globular cluster. So the way we identify objects in the night sky, most of them are either identified with an M number. Some of them have an NGC number. The M numbers, it's from a catalog back in the late 1700s and early 1800s. A French astronomer by the name of Charles Messier was a comet hunter, and he kept coming across these fuzzy objects with his telescope. And they didn't move, so he knew that they were not comets, but he didn't want to keep coming across them and trying to relearn what they were. So he started cataloging them. Well, as it turns out, a lot of these objects are some of the best things for amateurs to look at in their telescopes. And his ultimate list has 110 objects on there. So this particular globular cluster is M5, so that's the fifth one on his list. It's about magnitude 5.6, so it's just right at naked eye. We use magnitudes to determine star brightness and object brightness. Now, sometimes when an object is spread out over a big area, it may say like it's magnitude 6, but it's still fairly dim. So sometimes you still have to use your averted vision when you're trying to find it in the night sky. But generally speaking, anything with a magnitude of 6 or brighter, less, so a smaller number, is going to be visible to the naked eye if you've got decent skies. If it's a higher number, that means it's a dimmer object. So Bernie, whenever you're ready, you can grab the screen. This particular globular cluster is about 24,000 light years away. So, our solar system is 26,000 light years from the center of the galaxy. So this is looking back in towards the center of our galaxy, and globulars tend to be above or below the plane of the Milky Way galaxy. So this one's about probably right above the core of the galaxy. It's got somewhere between 100 and 500,000 stars. I don't know who counted them, but I'm glad I didn't have to. But it's pretty good sized. It's about 165 light years across. So that's a fair amount of stars in a small area. So if you were on a planet around one of these stars, you'd have quite a few stars in the night sky. Globulars tend to be some of the older stars in our Milky Way galaxy. This is one of the oldest ones. Bernie, anything you want to highlight there?
Yes, as you can tell, when I first brought this up, it was quite small on the screen there, and I had to zoom in on it. Globular clusters tend to be quite small, so it's not uncommon to have to use quite a lot of magnification on them, except for the larger globular clusters. This one is one of the smaller ones, so it did require more magnification. By the way, this one was discovered in 1702 by the German astronomer Gottfried Kirch. And he spotted it while he was looking for comets like Messier did. And this was long before Messier did his list. Messier did his list using a telescope. Well, this one is bright enough that it could be seen with the naked eye without a telescope. So that's why it was seen probably back in 1702 by earlier astronomers. they had quite a discussion on what this was. Messier thought it was a nebula. He thought it was a gaseous cloud. He didn't think it was a globular, but Herschel in 1791 was able to resolve it down to the individual stars, like you're seeing on the screen here, and therefore it was put to rest that this was a globular cluster. By the way, we use the highly technical term of glob sometimes for these objects, so we might use that interchangeably during the evening. Jim, anything?
Yeah, we heard that the age of this object is about 13 billion years old, and you get that with photometric and spectrographic analysis of the chemistry of the objects when you're looking at it and how long they've been around to get the signature that they do. But being that old, stars didn't really start getting formed until 13.5 billion years ago. It took about 300 million years from the Big Bang to really start getting the gas expanding or the plasma expanding and actually form atomic particles so that they could actually form stars. So this is barely 300 million years older than when stars were first forming, and yet it's still hanging in there. Well, that gives us a clue. And the clue, one clue is that the larger stars, anything bigger than about 8 times the mass of the sun, would have gone supernova many billions of years ago. So it's lost some of its population, but the black hole or neutron star, whichever happened to be the result of the supernova, is still hanging around in there. The rest of the stars we can see right now are average. They're average like the sun. We talk about the sun as being average in all ways but one. It doesn't have a binary partner. And these stars are around the size of the sun, up to maybe about 6 or 7 times as big as massive as the sun. So they're still going. They're still going along, but they're near the end of their lives too. It's like a beehive at the center of that object. The stars are moving very quickly around the core center of mass of that object. And when they're going so fast, they sometimes can have a collision in there. You could have the leftovers from an average-sized star that's gone out of existence and left a white dwarf behind, or possibly a neutron star from a supernova, or some of the stars themselves moving, but they can collide with each other. And what ends up happening is that material gets ripped back down into an atomic level that is hydrogen, and it comes back and forms a brand new star, and then makes what's called a blue straggler. So when you look into that thing, into that object, and you can sometimes see blue stars, or you see red giant stars. Those are the stars that are about the size of the sun but reaching the end of their life. So that Milky Way has from 150 to about, some guesses say 200 of these objects. Some galaxies, for example, the Sombrero, has 2,000, and some galaxies can go up to over 10,000 of these. So we're not quite sure why we've only got 150, and some other galaxies have many more. But they're old, virtually a retirement home for stars, and they're in highly elliptical orbits around the halo of the galaxy.
All right, excellent. Yeah, so that was a good discussion of globular clusters. Now what we're going to do is we're going to move to the north. We're going to take a look at a galaxy that's up by the Big Dipper. So let me kind of point out it's a little bit crowded here. Here's the handle of the Big Dipper, and there's the bucket. This is Ursa Major. So the handle is actually the tail of the bear, and then the bucket is down here in the core. If you can see the Big Dipper, you can always find north by looking up there. So you see the handle, and then you look at the bucket. These two end stars we call the pointer stars, and they always point to the North Star, Polaris. Polaris is in the handle of the Little Dipper, and there's the Little Dipper or Ursa Minor right there. Where we're looking at here is we're going to look at a galaxy that's in the area of the handle. So if you were to use the last two stars, this is Mizar and Alcor and Alkaid. You use these last two stars, it kind of forms a triangle off of those last two stars. And right out here, if you were to look with either binoculars or a telescope, and you might even be able to see this, let's see, it's magnitude 8. So you probably need a little optical help, but that's going to be the Pinwheel Galaxy. So that is, like I said, it's magnitude 8. It's about 22 million light years away. So the light we're seeing, when Bernie gets the scope on it, and Bernie, you can grab the screen whenever you're ready. When Bernie gets the scope on it, the light we're seeing is 22 million years old. So we're actually looking back in time as doing astronomy. And so we like to say that we're time travelers. You don't have to go any place, but you're able to look at what objects look like back in time. This galaxy is, larger than our Milky Way galaxy. Our Milky Way galaxy is about 100,000 light years across. This one's about 170,000 light years across. And it's it's nearly two times the size of the Milky Way, and it's probably got about 1 trillion stars in it. Bernie?
I'm just finished processing this one. It should clear up here just in a second. One of my favorite galaxies because of the amount of arms that are very evident in this galaxy. Oh, got a satellite coming through. M101 was discovered by the French astronomer Pierre Méchain in March of 1781, and he informed Messier about it, and Messier in turn added it to his list. The galaxy has more than 1,200 H2 regions. Now, let me explain what those are. H2 regions are hot, contracting molecular hydrogen gas clouds. Try to say that fast. These are star-forming regions. And if you look closely on the image here, you can see quite a few of them. There's one here, here's another one, here's another one, here's another one, here's another one. They appear as bright knots in the arms of the galaxy. Those are star-forming regions. They're hot gas clouds that are contracting down and will form stars. Now, they won't form just a star or two. They'll form hundreds or thousands or millions of stars, depending on the size of the gas cloud itself. But those are called H2 regions. And this is one of the galaxies that has the most obvious of the H2 regions in it. Jim? Oh, by the way, just to add in real quickly, M101 was recently featured in the June issue of a popular newsstand astronomy magazine. So if you subscribe to any of the newsstand magazines, check in your June issue and you'll see a very nice article on M101.
Okay,
All
the constellation for this object is Ursa Major, which also happens to have an asterism, which is a combination of stars that make a shape that we call that it's not a galaxy, but or a constellation, but the group of stars is just an interesting looking picture. Well, Ursa Major has the Big Dipper as its tail end, and that is a big an important cultural viewpoint for many cultures. We can always take a look around some cultures that think of it as a plow. They think of it as the Big Dipper, as we call it, and they think of it as, in the Hindu point of view. If you turn it backwards, it's actually the elephant of creation. It's got a big square body and a long trunk. And so if your children are misbehaving, you take them outside and say, the creator's watching, you better behave yourself. One of the best interpretations of that constellation is the revolving male, which is up there near the top. The revolving male in the Navajo culture is responsible for the security of the family. And so they see him as moving around the sky, and then across on the other side of the North Star will be the revolving female that we call Cassiopeia. And so what they say is that teaches us that if the North Star is the Hogan or the home fire, then everywhere you wander or wherever your wanderings take you, your responsibility is to focus on the family. So that's the point of view of the Navajo. And Jim?
All right, yeah, so it's kind of interesting. This is one of the nice things about using planetarium programs is that you can just by a click of the button, you can change from a Navajo view to back to the Western view and see the outlines. And so you can learn a lot about some of the different cultures and how they might look at the night sky. All right, so what we're going to do now is we're going to go take a look at a pair of galaxies, M81 and M82. So we don't have to move very far at all. We went from up here is where M101 is. Now we're down here by where the bucket is, just off the bucket. And this is M81 and M82. M81 is called Bode's Galaxy. It was discovered back in 1774 by a guy by the name of Johann Bode. Magnitude 7, so it's just outside naked eye limit. About 12 million light years away. Both M81 and M82 are about the same distance away. So they're probably in their own little group. It's got a supermassive black hole in the middle. And it's about twice as large. The supermassive black hole is about twice as large as M82 or the other galaxy. So this particular black hole is about 70 million times the mass of the sun. So that means that in a very small area, and that's why they call them black holes, because the gravity is so intense that not even light can escape out. So in this small area within the center of this galaxy, you could put 70 million times the mass of the sun. And this supermassive black hole is probably not much larger than than our solar system, or even smaller than our solar system. And then the other one is M82, which is called the Cigar Galaxy. And so M81 is a face-on view of the galaxy. And when Bernie gets the scope there, he'll grab the screen and show you what it looks like. M82 is an edge-on view. And so it's going to take the shape of kind of like a cigar, where it's fat in the middle and tapered at the end. And so there were all the lights being concentrated in the edge of the galaxy. So it's much more concentrated than what you'll see with Bode's galaxy. They probably have encountered each other about 100 million years ago. So they've done a little bit of dancing around each other. The black hole at the center of the Cigar Galaxy is about 30 million solar masses. So it's about half the size. And then we'll see. Bernie, are you about ready to grab the screen?
I am. I'm just working on trying to get that other object that we were going to surprise everyone with.
All right. Well, hopefully it'll show up. You can see it's kind of a busy area with constellations, and looking up to the north, there's a giraffe, and you've got the Big Dipper and the Little Dipper and a dragon. So yeah, it's a pretty exciting place.
Okay, let me swing over to it. And I'm going to grab it now from you.
Okay. Yeah, I really enjoy looking at the cigar galaxy, M82 in particular, because the light is so concentrated that it shows up nicely in virtually in most any kinds of telescopes.
So as you can see in the upper right corner there and more down below is M81 and M82. This is M81, this is M82. And the beautiful part of M81 is its large S-shaped spiral arms. Amongst the galaxies that are visible in the night sky, Andromeda, of course, is the big showpiece. And that's the one that we love to show people. Unfortunately, this time of year, it's not in the night sky, so we can't show that to you. However, we can show you the other big showpiece galaxies, M101, which we just looked at, and M82. M82 has these beautiful spiraling arms in a nice S formation, and M82, on the other hand, is not quite so spectacular because it's shown edge on. So we have both an edge on and a face on galaxy in the same field of view. M82 is a very active galaxy. There's a lot of new star formations going on in that galaxy, so it tends to be very bright along the central core. Let me see if I have another note or two that I wanted to mention on that. No, not on that particular galaxy. Now, we have a little surprise for you. M81 and M82 have a neighbor that's passing by right now. And if we scroll down, you get to see it. It's right at the bottom of your screen. And this is called Comet Pan-STARRS. P-A-N-S-T-A-R-R-S. It was discovered in 2017, and it's slowly going through our solar system. I believe it's already past the sun, and it's got somewhat of a tail. You can just make it out there. Actually, it's quite a bright tail today. Here's the coma. It's the brightest part of the comet, and then the tail is streaming back this way. And I'm not sure if you can see it on your screen, but I can see the tail reaching back maybe about this far. Kind of difficult, but it has a nice streaming tail this evening. You'll also notice that it has a greenish tint. It's not uncommon for comets to have a greenish tint. It seems to be very typical in our comets. This one is greenish because there's a cyanide derivative in the molecular cloud that's part of that icy snowball. And that's why it's glowing in greenish like that. It passed the sun on May 4th. I just looked it up. It was on May 4th that it came closest to the sun. So it's on its way back out again. And it's in a 450,000 year orbit. That means that you probably don't want to wait around for the next time it comes by. Jim, were you going to mention something about
Yes, coma, we call that a comet, and it's derived from the Greek language. in which coma means hair and a comet is a hairy star. So that's how the terminology we use for it, comet, came about. It was just a hairy star to the Greeks.
All right. Yeah, thanks, Jim. So that was it. That's kind of interesting. I'm glad we were able to take a look at the comet. It was nice that it's very close to a couple of the galaxies in the night sky. So that's a heck of a treat. So now what we're going to do is we're going to move from the north and we're going to go down to the southwest a little bit. So let me show you where we're looking. So now we're going to go back down to Corvus the Crow. And we're going to look at a pair of galaxies that are kind of interesting. These are called the antenna galaxies. And so what's happening here is that these galaxies are actually in the process of interacting with each other. So earlier we talked a little bit about our local group of galaxies. And so, you know, around us, we've got the Milky Way galaxy is our galaxy. And then the other large galaxy in our little local group is Andromeda. And we're slowly in the process of getting closer and closer together. And in about 4 to 5 billion years, our galaxies will merge and will become one huge elliptical galaxy. Well, a lot goes on when galaxies merge, and it's just not a simple process. Now, there's a lot of empty space out there, and so most of the time, stars miss each other and things just kind of mix up. Sometimes stars and planets can get flung around, but for the most part, the actual merger is just takes place. Well, these two galaxies actually collided several 100 million years ago. And so they are interacting, and within probably another 400 million years, the cores of the two galaxies will settle down and become one central core. So right now, and Bernie, you can grab the screen whenever you're ready. When Bernie shows it to you on the telescope, you're gonna actually be able to see the two galaxies still separated. And that's why we call it the antenna galaxies, because it kind of looks like an antenna. It is one of the nearest examples of colliding galaxies. Like I said, it's not very far away at all. It's, let's see, it had two supernova that took place back in 2004 and 2007. The galaxy itself is 63 million light years away. So it's in our area, but it's not, you know, by any stretch of the means, any of the closest galaxies. But like I mentioned earlier, it's going to be kind of what the Milky Way and the Andromeda are going to look like in 4 to 5 billion years as we start that process of merging. And chances are, when we merge with Andromeda, all of our satellite galaxies will move with us and merge with us. So again, we're looking in Corvus the Crow. So it's fairly far south and southwest. Zoom in a little bit here and you can kind of get a little taste of what we're looking at here. Right here's the two galaxies merging together. They also call this the ringtail galaxy. Magnitude about 10 to 11, so it's not really a naked eye object.
Yeah, this is a tough one. You're challenging me on this one.
Yeah, it's pretty far south. It's not really bright. It's probably going to take a little bit to tease it out. Oh yeah, you can see it all right though.
That's a tough one. What I was hoping to do, as you know, this pair is called the antenna galaxies. That's one of the other names for it. And the reason it's called the antenna galaxies is because not only do you have the two galaxies kind of colliding into one another, but just faintly and you can just make it out, the collision of those two galaxies is putting such tidal forces on the galaxies themselves that there's actually a spray of stars that arc out like that. And I don't know if can you see that? Can you see that little arc going
It's
off
pretty
this
faint,
way?
but yeah, it's pretty faint, but you can see it.
And then there's another one that goes this way. So there's two little arcs of stars that were forced out of the main galaxy itself, probably one from each one, as the gravitational tidal forces ripped them apart. So there's an arc of stars there, and there's an arc of stars there that were torn away from those galaxies. If it wasn't quite so far south, I could probably pull them out a little better, but you can just make it out. That's why they're called the antenna galaxies, because those two arcs reminded us old people that of the old TV antennas, the rabbit ears that we used to have on top of our television sets.
Yeah, that was a tough one. It's pretty faint. Seems to be a fair amount of background glow. Is that sky glow showing up, Bernie?
It is, and you know, if I pulled the sky glow out, these would probably just fade right out. So
right.
it's actually better for me to leave a little bit of the sky glow in. It would take quite a bit of teasing to get it any further, and certainly not in the time frame that we've got here to deal with this.
Sweet. All right. Yeah. So that's a fun one to look at. It's interesting to see galaxies in the process of merging like that. So I would imagine if you were on a planet around, a star in one of these galaxies, you would have an incredible view in your night sky. You would have arcing, if you've ever looked up, especially if you've been to the Grand Canyon before, but if you've got some dark skies in the summer and you look at what we call the summer Milky Way, you look up in the night sky and you can see the arc of gas and dust arcing across the night sky. And that's the Milky Way. And what we're actually seeing there is we're seeing the next band or the next arm of our Milky Way galaxy in towards the center. Well, in this galaxy with a merging like that, you may have multiple arms coming across and crossing each other. You're going to see, streams of stars and gas and dust and all kinds of cool things in the night sky. So that's really interesting. It would be really, really cool to see in person. All right, so we're going to stay on Bernie's screen here, and he's going to show you moving the telescope to probably a much easier object to spot, and that's a globular cluster near Antares in Scorpius.
Right, we're going to shift over to M4 or Messier 4. So first I'm going to scale this back down again. You can see how small those are. They're tiny. And I'm going to move my processing screen in so you've got an idea of what that looks like. And going to go to what's called the default histogram, turn off the average stacking, and probably go to a shorter exposure time because globulars tend to be quite bright. So don't need to be anywhere near that bright. And why is it looking up on me? Okay, there we go. Oh, that's the reason why. All right, let's do it that way. Got to turn the right function box on before it's going to function, right? So I'm going to off screen to my astronomy program here that allows me to steer the mount and plug in M4. And I'm going to ask it to take us to M4. So I just did that, and now you can see streaks on the screen. What you're seeing there is the tripod or the camera is still running. So as the telescope slews over, it's swinging by stars and objects in the sky, and that's what the streaks are. So once it settles in on the object of interest, then that will settle down and we'll get to see M4. And I think it's just about there. I think we had to do a meridian flip there, so it's going to take a little while. There it comes.
So while the system's kind of settling down, so
There we go.
M4 is a globular cluster in Scorpius, and it is right adjacent to Antares, which is the heart of the Scorpion. So I don't think we can see Antares in this particular shot, but Antares is also called anti-Mars, but because of its red nature, but it's right next to the star in
Actually,
Scorpius.
I think I had it. It's right up there in the upper left corner, Jim.
Yeah, there it is.
This is Antares right up here. So I'm going to purposefully keep that out of the field so it doesn't cause glare into our image.
And if you want to highlight anything else about that, Bernie.
M4 was cataloged by Messier in 1764. And an interesting note on M4, it was the first globular to have its stars resolved. Up until then, they didn't know what globulars were. They were just kind of fuzzballs. They couldn't, they weren't sure what it was. But as telescopes improved, they reached the point where you could actually resolve the individual stars, much like we're seeing here on the image, where you can see the individual stars in the within the globular. And once they were able to resolve it, then they understood what it was, a vast concentration of hundreds of thousands or even millions of stars. You know, I've never actually noticed it before with M4, but there's an alignment of stars in a straight line there that I don't think I've actually noticed on M4 before.
Yeah.
I doubt if it's anything new. I just don't remember it being there before.
Yeah. Interesting. So, Jim, why don't you talk a little bit about the lore associated with this?
Okay, first I'll say that not only was M4 the first one that got the stars resolved, so you could see individual stars and not just a smear or a blob. You could actually see the identity of stars. A good number of the stars they saw were red giants, stars at the end of their life. And that's when they were using some of the analytical basis to start getting the age of these devices out, of these objects out. and the red dwarfs fit, the red giants fit right into that kind of concept because it showed that they were average sized stars, but near the end of their life. So that meant they were somewhere between 10 and 12 or 10 and 13 billion years old. And as far as something else, Jim, are you going to show the shape of Scorpius, or are we going to just?
I can. Let me grab the screen from Bernie, and while I'm doing that, Bernie, if you want to set up for the next one, that's fine.
You sure can.
So here's the screen showing Scorpius.
And if you Scorpius is a set of stars when you look out, looks very much like a hooked backward J in the sky. When the Navajo came down from Alaska around 600 AD, they did not know what a scorpion was. Instead, they saw the upper curved part as a wise, elderly tribal member showing people how to plant seeds. The bottom part of that scorpion, they call rabbit tracks because they didn't know what a scorpion was. So that figure that they see in Navajo is called the first great one. And Jim's going to call up that sketch right now of what that looks like for Navajo. And as you can see, the first big one or the first great one in the middle of the screen, that long stick on the viewer's right-hand side is the planting stick. That shows how they're going to make holes for the seeds, while the other hand is throwing the seeds into the holes that have already been made. It does not have a gender, but it's also got a second name for the Navajo. It's also called the mother-in-law. Now, we know that there was, from Greek legend, that the scorpion killed Orion after Orion had chased the daughters of the moon into the sky as what we call the Pleiades. Well, that did make Artemis very happy. Her brother Apollo got a scorpion, which is what we're looking at there, and made it kill Orion, and just before he died, he killed the scorpion. Well, Zeus was very upset about this, so he put the scorpion in this part of the sky where it is, and he put Orion in the sky almost exactly opposite it, so you never have both Scorpius and Orion in the sky at the same time. Well, if it was at the right time of year and we had Orion up, that is called the first thin one for the Navajo, a warrior example. He's also called the son-in-law. So this is the mother-in-law, and the one we can't see right now is the son-in-law, and they're never both up at the same time. So when a Navajo girl gets married, it's tradition, if they're living up on the reservation, that her mother and her new husband can never see or speak to each other again for the rest of their lives. So that's almost an example of what the Greeks do, except they do it with the scorpion and Orion. The Navajo do it with the mother-in-law and the son-in-law, the same constellations.
Nice. Yeah, so that's a good description of different cultures and how they see things differently in the night sky. So what I'm going to do is I'm going to switch views again and go back to our Western view. And we're going to go to, and how's this one looking, Bernie? All right, good. So we are now looking way down towards the southeast. You can see it's barely starting to rise in the constellation called Sagittarius, or the Archer. Let me turn off the ground here. You can see the rest of them. So this is the rest of the Archer down here. So it's just barely coming up right now. And where we're going to be looking is right up there. And this is called M24, or the Sagittarius star cloud. Bernie, you can grab the screen whenever you want to go to it. It's a cluster of stars spread thousands of light years across, as if you were actually kind of looking down a tunnel at the stars. So it's almost looking like a time tunnel kind of thing as you're looking down to what is basically a hole in the dust and gas of our Milky Way galaxy. It's a magnitude 4.5, gorgeous, gorgeous star cloud, as you can see in a telescope. And you can just, it's just thousands of stars lighting it up. Easy to spot with binoculars. It's between 12 and 16,000 light years across. And so it's, like I said, it's kind of a chance hole in our Milky Way that allows us to be able to see through and see all the stars behind. Bernie?
Yeah, M24 was discovered by Messier and, of course, put on his list in 1764. And as Jim was describing, this is not a nebula. It's not a galaxy. It's not an open or globular star cluster. It's a window into the center of our galaxy. So this area is the stars that are deep into the center of our galaxy, whereas the surrounding area has less stars. The reason for that is because there's clouds of interstellar gas that block the light from those from the billions of stars that are back there. So you can't see those stars because of that gas, that dust and gas that's present there blocking that light. And in some areas, the blockage is so dense that it actually creates black areas, like right here is a very good example of a very thick dust area. And over here as well. And up here in this area. And a bit of it over here too. So what we're just looking deep into our galaxy's core by looking at this star cloud, if you will.
Yeah, and this looks, I mean, just amazingly awesome in the telescope, both visually and with the camera, obviously. So I'm going to grab the screen back from you if you want to move to M20, and I'm going to show just a little bit, more about where we're looking. So if you were to, summer Milky Way, when you look down towards the south, you can see Sagittarius kind of looks like a teapot. So as you're looking down there, you'd see what looks like an old-fashioned teapot. So here's the handle, there's the spout, or the top, here's the spout. So this is called the teapot of Sagittarius. And where steam would be coming out of the spout here is the center of our Milky Way galaxy. So that's why there's so many cool things to look at down here. We're looking back in towards the center of our galaxy, and there's just lots and lots of stars and gas and dust and nebula and all kinds of cool things to look at. But you can clearly see the outline of the teapot if you were to look to the south, if you've got a good clear sky to the south. And that is part of Sagittarius. And so you can kind of see with the teapot, the spout is forming the outstretched arm as he's pulling back on the bowstring. All right, so that was M24, the Sagittarius star cloud. Now we're going to look at M20, which is a nebula inside the not too far away, and that's a really cool one to look at as well. Just right next door. And this one, and Bernie, whenever you get the scope ready, you feel free to grab the screen. This one, okay, this one is called the Trifid Nebula. So this is a nebula of gas, a stellar nursery basically, and it's got some dark lanes going through it. So as Bernie was talking about in the star cloud, where when there's some dark areas, that's the gas and the dust that we can't penetrate through. We can't see the stars. You know, the stars that are glowing from behind are blocked by the dust and the gas. Well, the same thing is happening here in the Trifid Nebula, but instead of being just blobs of it, there's actually some lanes going through, and it divides the nebula up into 3 equal areas, and that's why they call it the Trifid. And so it's got some nice dark areas going through it. You can't spot it in binoculars. It's about 5,000 light years away. The left side, so if you think about it, this is 5,000 light years away. So the light we're looking at is back in time 5,000 years. So when Stonehenge was being built in Britain, that was about 5,000 years ago. So the light that left that nebula is reaching our eyes. It left the nebula back when Stonehenge was being built. Bernie?
M20 is one of my all-time favorite nebulas to look at. As you can see on the screen, there are areas that are pinkish red. There's areas that are bluish. There's 3 different distinct types of nebulosity, all wound into the same nebula. So the pinkish red is emission nebula from hot ionized hydrogen. The dark areas that Jim was discussing is the dark nebula, and it's bisecting it up into three different lobes or sections. You can also see part of it going off to the right. And then also is this beautiful bluish area that is reflection nebula. And that's blue because there are some hot, there's young blue, super hot stars there that are emitting so much light that the light from those blue stars is reflecting off of the and reflecting back at us. So here we have all 3 different types of nebulosity all wound in to the same beautiful nebula. And I think it's one of the reasons why they call it the Trifid. I've heard others call it the Trifid Nebula, or tri, meaning 3. I don't know if that's the reason for the name, but I've heard it called that as well.
And one of the key differences between looking at objects through a camera like Bernie's doing and looking visually through an eyepiece is that with the camera, you get the colors that he's pointing out there. With our eyeballs, because most objects are so dim and our night vision is not all that good, generally speaking, we only see shades of gray. So in here you'd see kind of a gray, ghostly object with the dark nebula going through it. So you don't see the bright colors as well as you would with the camera. So it is different kinds of viewing that just a different experience.
My experience, Jim, in looking at this with optically is you see this part of it because it's bright and it's reddish. You can't see the red, but it's brighter for that reason. Whereas the blue nebulosity is rarely seen by the human eye. I've never seen this part of it.
It's just, there's not enough contrast and it's too faint to really be able to pick it out.
Correct.
So yeah, this is one of my favorite ones. I always go to it at the Grand Canyon Star Party visually because it is such a treat to look at. There's a lot of cool things, on this part of the sky. We never get tired of looking in the Sagittarius area. So let me grab the screen and we'll take a look at the next one. So we're back to Stellarium again. We're still in Sagittarius. So looking down here. And now we're going to look at M8, which is called the Lagoon Nebula. So again, This is another nebula similar to the Trifid Nebula, but in this case, instead of having multiple dark lanes going through there, it's just got one kind of going down through the middle. And that's why they call it the Lagoon Nebula, because it looks like a river running through the nebula. The Lagoon Nebula is it's a stellar nursery, so the nebula itself is making new stars. It is divided up, like I said, by an interstellar gas cloud. The cluster that you'll be able to see in the nebula is some of the very young stars. And it's just like the Trifid, it's an emission nebula as well. And so it's being lit up by ionized gas. So it's making its own light. It is right at magnitude 6, so it's probably one that's barely visible to the naked eye. If you had some really dark skies and used maybe your peripheral vision a little bit, you'd be able to see it. Certainly, you'd be able to see it with binoculars. It's fairly close. It's only about 4,000 light years away, so it's not very far away at all. And the long dimension of it is about 130 light years long. So there's quite a bit of gas in there that can be making new stars. So it'll be interesting. And as we've talked about, as stars are formed and they use up the gas, then the nebula itself would disappear. And what you'd end up with is an open cluster. And this open cluster would orbit around the Milky Way as a group. Our solar system, our distance from the center, it takes us about 225 million years to make one revolution around the Milky Way galaxy. So we've been in existence for 4.5 billion years. So we've made 19 to 20 trips around the Milky Way galaxy, and so as we do that, it shifts as we're going through different neighborhoods as we go through. And there it is. Go ahead, Bernie.
Yeah, M8 is one of my favorites as well. It's more of a summertime constellation object. It's best seen on a nice summer evening when you have the Milky Way kind of banding right through the middle of your sky. But it's visible at this time of year too if you stay up late enough. M8 was discovered visually by an Italian astronomer, Giovanni Odierna, around 1654. So again, about 100 years before Messier did his list. But this is such a bright object in the sky that you didn't need a telescope necessarily to see it. It was probably easy to point out and say, that's something in the sky. It has a lot of pinkish red around the borders. That's all, again, ionized hydrogen clouds that are part of the stellar nursery area in the center. I've overexposed the center, that's why it's so bright, but I've done that intentionally so that you can see those outer lying clouds that form kind of a circle all the way around it. And it's much like the Orion Nebula in that respect, that it has a large circular gas cloud that has formed around it. Now, one of the interesting things in there is you can see there's a lot of stars that have formed in that gas cloud, but this cloud also has some things that are a little more harder to spot, but they are visible in this particular gas cloud, and that's called Bok globules. Bok globules are dark, collapsing clouds of protostellar material. And if you look closely, here's one of them. That is a Bok globule. Here's another one. And I believe there's some more right here and possibly another one over here. There's quite a few of them, but those are the more obvious ones. Those are dark collapsing clouds of protostellar material. In other words, gas that is collapsing down that will form a star sometime in the future. Don't wait up for it. It's not going to be in our lifetimes, but down the road, there'll be some new stars there.
Yeah, and Vern, if you kind of highlight the center dark area, that's the lagoon. So generally in visual telescopes, you're going to see the bright areas that are on either side, and then you've got that dark lane going right down the middle of them.
Mm-hmm.
And that's what'll show up primarily in telescopes visually. But yeah, that's a really, really cool one to be able to look at. All right, now we're going to slide just a little bit further over and back into Scorpius. So we're moving from here, we're sliding right over here to Scorpius, near the tail of the scorpion. So as we looked at earlier, there's Antares, the heart of the scorpion, and it kind of swings down and around and then comes back up right there. So what we're looking at now is an object that's called the Cat's Paw Nebula. And you can kind of see a little bit of it there. It's starting to take on the shape of what you might envision as being a cat's paw. And so this is an emission nebula as well. So it's similar to the Lagoon Nebula. It's making stars. It's a stellar nursery. It's near, like I said, near the scorpion's tail. It's about 5,500 light years away, and got a lot of large stars in there that are probably 10 to 12 times the size of the sun. So stars of that, usually some of the first stars that are born in these nebulas are huge, huge stars because there's a lot of gas and material available to be able to see and for them to be able to use. So the first ones is kind of like the oldest, the first ones on the scene get most of the food. This nebula was born in the past few million years, so most of it's still quite active. It's about 50 light years long, so there's a fair amount of star material there. It's actually capable of producing about 200,000 suns worth of material. Now that would be suns of our size. So if some of these large stars that are 10 to 15 times the size of our sun are going to use up a lot more material. It's home to probably about 2,000 extremely young, hot stars right now, and that's what's producing the glow. So again, we are looking in right at the back claw of the scorpion. So still pretty far south. The southern, the southern constellations don't get really high for us. So a lot of these are more for, if you're down in the equator or down in the southern hemisphere, they're going to be pretty high in the sky. But for us here, since we're in the southern part of the U.S., we've got an opportunity to be able to look at them fairly well.
I'm there, Jim, so I'm going to grab it from you.
All right.
So here's the Cat's Paw Nebula. I have a cat, so I liked the name and immediately appreciated this particular nebula. And as you can see, it has 4 somewhat distinct lobes, 3 of them. You can say there's a 4th there, and a central pad. So it kind of looks like a cat's paw. And these are all ionized gas clouds of ionized hydrogen. Looks like the the divider between the upper two might be, yeah, that looks like a dust cloud that's bisecting it. Be my guess is that that upper cloud there actually goes all the way across, and that dark cloud is just bisecting it visually from our vantage point. The was originally discovered in 1837 by John Herschel while he was in South Africa down at the Cape of Good Hope. And I first imaged and saw this at last year's Grand Canyon Star Party. I wasn't aware of this particular nebula until the person who was imaging next to me mentioned that I should go check it out, and it's become a favorite of mine ever since.
Yeah, it's a gorgeous nebula. There's, you know, the red area that you're seeing there is probably the nebula is, you know, probably all red throughout, and then we just got the dark, heavier gas and dust in between us. So visually, it splits it up into different lobes.
Mm-hmm.
But yeah, that's an absolutely gorgeous, gorgeous nebula. All right, just a couple more objects to do tonight. So where we're going to go now is a little bit off of Scorpius Sum to a cluster called M6, or the butterfly cluster. In a little bit. And so this is going to show as an open cluster of stars. There's the telescope generally will show about 300 stars when you're looking in there. Visually, you know, most of the time you can probably see maybe 80 or so. It's a magnitude 4, so it is naked eye. And it's about 1,600 light years away, so it's in our stellar neighborhood. 12,000 light years across, so it's fairly good size, but you know, not for that many stars. 12 light years is not very far, like I mentioned earlier. Our nearest star system is 4.2 light years away, so you know, that's 3 times the distance, and we've only got one star, and there's you know, hundreds of stars in this one. So again, your night sky is going to have quite a few clouds, or quite a few stars in the sky. It's a fairly young. Most open clusters are fairly young. This cluster is maybe only about 100 million years old. When Bernie grabs the screen and we look at it, take a close look at it, and you know, see if you can see a butterfly. A lot of times when you look at clusters and asterisms and things, everybody's going to see it differently. And some people will see, you know, something really odd that you're not even anywhere close to, and others will be able to will see what you see. So it just kind of depends on your background and what your frame of mind is when you're looking at it.
So here's the butterfly, and you can kind of make out the wings and the body of the butterfly. As Jim mentioned, this is an open cluster. The M6 was first cataloged by Giovanni Odinurna in 1654, 100 years before Messier, but Messier added it to his list in 1764. So it did get on the Messier list eventually, and it's called the butterfly cluster.
And it certainly does look like a bird or a butterfly of some sort with wings coming out on either side. So it does, and as we mentioned earlier, most open clusters are fairly young. So the stars in this cluster are generally about 100 million years old. All right, so that is the butterfly cluster. All right, so our last object for the night, this is a cluster of stars called Ptolemy's cluster. So it's again down here along the stinger of Scorpius. It was discovered back in 130 AD, and they call it the little cloud following the stinger of the scorpion. So this, zoom in here a little bit, can't really see the cloud. We'll show it to you on Bernie's telescope here in a minute. But as the scorpion migrates across the sky, this little cloud follows it. It's a huge open cluster, visible to the naked eye, about 80 stars, fairly close to us at 1,000 light years away, and a diameter of maybe 18 to 25 light years. So Bernie, go ahead and grab the screen. Like we talked about earlier, most open clusters are fairly young. So this cluster is about 220 million years old. And if you can look at it, again, from a fairly dark sky, the stars in the cluster might just kind of pop a little bit, and it'll look like some diamonds on a black velvet sky. Bernie, you can
This
talk
is,
a little more.
This is one of the southernmost, in fact, it is the southernmost of the Messier objects at minus 35 degrees declination. But it's fairly easy to spot on a clear, dark night from northern locations. And to me, it has kind of a shape of an H or an A, perhaps, with two arms and a central bar across it. Various people can see different shapes depending on which orientation you're looking at. But from this angle, it kind of looks like an H.
Yeah. All right. So I'm going to grab the screen back. And going to give you one last little look at a different nighttime picture from a Grand Canyon star party with all the red lights lit up and the Milky Way going in the background. So I hope you guys all enjoyed our little virtual tour around the night sky. Again, I wish we could have been able to do it in person, but I think this is a great way and probably a nice way to be able to share it to a lot more people. Hopefully, you know, if this works well, we might even next year be able to do a virtual star party in conjunction with the live one and bring in audiences from all over the country and all over the world. So I think that would be just totally awesome. If you're planning on doing the Grand Canyon next year, our star party is scheduled for June 5th through the 12th. 2021. So it's come on up and join us. And again, I hope everybody had a good time. I'm going to pass it over to Bernie for any last comments, and then we'll call it a night.
Thank you, Jim. Hope you enjoyed our tour of some of the night skies objects. We certainly enjoy doing it for you. And with that, next year.